Hi guys, so for today we are going to talk about Newton's law applications, and this is a continuation of my video about physics. Okay, I'll be consistently uploading again physics because this is the fundamentals of engineering. Okay, and for today we are going to solve some problems involving the Newton's law applications. So let's get started. We have 8 problems here. Okay, so as you can see, so the reference of these images are from University Physics from Young and Friedman. The author is Young and Friedman. So let's get started. What is the acceleration of toboggan loaded with students of total mass of 500 kilogram sliding down a friction-free slope? Assume that the angle alpha here is 15 degrees. So the very first thing that we're going to do in order for us to solve Newton's law applications problem, of course, we have to draw the free body diagram. So as you can see, we have the weight here. Oops, it's just too big. Okay, the font is too big. Okay, let me choose a smaller font. So we have the free body diagram. We have the weight, and we have the normal force, and of course, in this direction, we have the component x of weight, and of course in this direction we have wy also, and we have wx. Okay, so it says friction free slope, so we don't have any friction opposing these students. Okay, so the free body diagram is labeled as this, and then of course we have to take note that the base where they are sitting is inclined with alpha, angle alpha. So where do you put the angle alpha? The angle alpha is always, okay, in the y-axis. Okay, so this is our y-axis, tilted y-axis. So this would be your alpha. Okay, so and because of that, okay, because of that we have the formula summation of forces, okay, along x. Of course we have the students are moving. It says they have an acceleration, so by second law of motion we have summation of f of x equals ma. So because the students are at motion, they have an acceleration. So if we try to sum all the summation of forces along x, we'll be having wx, or the weight component in terms of x. Okay, and there's no any other forces acting on x because it is frictionless. So we have ma. Okay, and how do you get wx? Okay, so how do you get wx? Of course, from this figure, this is our free body diagram. We have wx here, we have wy here. Okay, so if we are going to make a triangle, a w being the hypotenuse, and you have the wy here, and you have the wx here. So if I'm going to move this, I'm going to extend this. I'm going to move this wx here. Okay, so this will become wx, and this is our right angle, and this is our angle alpha. Okay, so in order for us to get wx, of course, we know that that would be what? That would be sine. Okay, opposite side over the hypotenuse. So if you get wx, if you get sine alpha, so that would be sine alpha. So opposite of the alpha is wx. Okay, all over the hypotenuse, which is the weight. So technically, wx is w sine alpha. Okay, so we have w sine alpha equals ma. And we are being asked what is the acceleration. Okay, so we have the weight. Weight is converted as mg. Sine alpha equals ma. Okay, and we know that m's will cancel. Okay, so we have m and m here. So we are being asked to find for the acceleration. It's just simply g sine of alpha. And if we are going to solve that, we have acceleration 9.81 meters per second squared multiplied by the sine of 15 degrees. We'll be able to get the acceleration from your calculator, and that would be 2.53 meters per second squared. Okay, so the very first thing is we're going to just get the free body diagram acting on that particle, and if it is accelerating, of course, on the right side, we have acceleration, ma, and if it is a constant speed, of course, that we will not be having any acceleration because constant speed. Okay, so that's the acceleration of the students or the toboggan. Okay, for number 2, a 500 Newton cart connected to a bucket by a cable passing over a pulley. Okay, what mass of the bucket is needed for the system to move up? Okay, the incline 15 degrees with constant speed. So I'm going to copy this first, these two images, so that we'll be having another space for solving this problem number 2. Okay, so the first thing that we're going to do here is to take note of the following. Okay, we have two objects here that we can have a free body diagram. We have the cart, we have the weight of the cart, okay, we have the normal force, okay, on the cart, and of course we have a tension in the cable because it's connected into a cable. Okay, and the one that is being asked is what should be the mass of the bucket, okay, is needed for the system to move up 15 degrees incline with constant speed. So meaning it should have a constant speed. The bucket should have a constant speed. Okay, so if the speed of the bucket is constant, and it since they are connected in a cable, so it must be that the cart also has a constant speed. So the constant speed, okay, here denoted by with constant speed, meaning the speed of the cart equals the speed of the bucket because they are connected in a cable. So if there is a constant speed, meaning the acceleration of the system should be 0. Okay, so kindly take note of that because there's no change in the velocity. So there's no acceleration. It's constant speed. Okay, so fortunately there is no friction. Okay, so that we will not be able to have a problem with the friction. So of course, if we draw the we have the weight of the cart. This is our y-axis. Okay, and of course we will be having another x-axis here. So this is our y, this is our x. Of course, our weight for the cart will have wy, and you have wx, x component and y component. So this 15 degrees incline is always attached to the y component. So that will be 15 degrees. So if we wish to draw the block diagram in details, so you have n, you have t here. This will be your y-axis where your w of y also. This will be your weight, and of course this will be your wx, and this will be your angle. Okay, this is your normal force, this is your tension in the cable. So if I'm going to just simply move wx, I'll be forming a triangle wherein this will be my wy and this will be my wx. So this means wy, this is wx. Okay, so the hypotenuse will be the w. Okay, and this will be the angle 15 degrees. Okay, so now this is the FBD of the cart. Okay, that's the FBD of the cart. How about the FBD of the bucket? Okay, so for the bucket, it's just simple. So you have weight of the bucket and then tension. Okay, so there is a summation of forces in terms of y, and that is equal to ma. But since we have a constant speed, then a is 0. So you have summation of Fy equals 0. Okay? So we need to get the mass of this. Okay, so that would be T minus W equals 0, and T should be equal to mg. And we don't know the mass. That is what is being asked for the bucket. So if we get the mass, we have T all over G equals m. Okay? But again, we don't know the tension. And the tension here is the same as the tension here. Okay? So we need to get first the tension here. Okay, in the cart. So if you're going to do summation, okay, if we're going to do summation of forces along x here, summation of forces along x should be 0 because MA, constant speed, is 0 for the cart. Okay, this is summation of forces for the cart. So you now have for x, this is your y, this is your x component. So to the right, we have the tension minus Wx equals 0. And what is Wx? Okay, Wx based from this triangle, okay, based from this triangle is sine of 15. So if you get sine of 15 degrees, that would be opposite, that would be the Wx all over the hypotenuse here, which is the W. So Wx would be Wx equals W sine 15 degrees. So this would be T minus W sine 15 degrees equals 0. So now we have the value of the weight of the cart. That's 500 newtons. So we can get the tension by just transposing W sine 15 degrees to the right side. So now we have tension equals the weight of the cart is 500 newtons times sine 15 degrees. And 500 newtons times sine 15 degrees is 129.4 newtons. Okay? So that is not the answer. The question we are being asked is what mass of the bucket is needed for the system to move up with a constant speed of 15 with a 15-degree angle. So from our summation of forces along y in the bucket, we derived this formula a while ago that m equals tension all over G. And this tension is the same as this tension. Okay? So because they are connected with a cable. So now that we got the tension, we have 129.4 newtons all over 9.81 meters per second squared. The mass should be of the bucket should be 13.2 kilograms. Okay, let us check if that is correct by our calculator. So we have a Cars emulator here. Thank you so much, Cars, for sponsoring me this free emulator. Okay, so I love their calculators because it's much similar to my previous calculator, which is no longer allowed to the board exam. But this one is allowed in the board exam. So you have 13.2 kilogram, and that is correct. Okay? That is for our number 2. Okay? So physics is not that hard if you just know how the concepts are derived, if you just know how to have the free body diagram of these particles, and then you're good to go. It takes constant practice. So we have so many problems to solve. Let's go now to problem number 3. So find the magnitude of the acceleration of the system if m1 equals 2 kilograms and m2 is equal to 5.5 kilograms. Inclined angle is 32 degrees. Okay. So, yeah, we know that the acceleration of this system, since they are connected with a cable, the acceleration of the mass 1 is the same as the acceleration of mass 2. Okay, but first, we need to draw the free body diagram, the FBD. Sorry, that's only FBD, not summation. FBD for mass 1. Okay, so if we have the FBD for mass 1, we have the weight of mass 1 all over On the upside is the tension of the cable. Okay? So we have summation of forces along y. Since we have an acceleration, that should be equal to ma. The problem doesn't state that we have a constant speed. So we have an acceleration already. So that would be T minus W1 equals ma. Okay? So more specifically, we have T minus the mass of W1 or the weight 1 is M1 times G. And that should be equal also to the M1 of A. Okay? Because we are talking about the acceleration of the mass 1. So we should have M1 here. Okay? So let's just take a look. This will be our equation 1. Okay? So how about for the FBD of mass 2? Okay? Or the second object. So for the FBD of M2, we have the weight. We have the tension on the X. We have the normal force here. Okay? And there is no what do you call this? There is no friction involved. So it's much better. So if you draw the free body diagram, that would be the weight of mass 2. The box 2, this will be the normal force. And this will be the tension. So take note that this is our x-axis. And take note that this will be our y-axis. And our W has component WX and WY. So since we have an angle, the angle is always here. The angle is always from the weight to the y-axis. So we have an angle of 32 degrees. Okay, so if we draw the triangle created by the weight and its component, so now we have this one for the WY, and for the X would be this. So we can rewrite it here. So this will be our WX. So this will be the right angle. Okay, and this will be the angle 32 degrees. Okay? So that's the more detailed, okay, drawing of the triangle of the W component in terms of X and Y. So how about if we get the summation of this summation in terms of X? Okay? That would be M2 times A. Okay? Because the object 2 is also moving. We have an acceleration. And take note, the acceleration of this box is the same as the acceleration of the M1, which is the spherical ball. Okay? So summation of F of X going to the right positive. So we have WX minus the tension equals M2 times A. And then WX, okay, what will be the WX? So if you get the sine 32 degrees, that is so opposite WX all over hypotenuse, which is W. So you have W sine 32 degrees equals WX. Okay, so you have W sine of 32 degrees minus the tension. We don't know the tension. And we have M2A. Okay? And of course, the W, we can rewrite this as the weight of the mass 2. That would be the mass 2 times G times sine 32 degrees minus T equals M2A. Okay? This will be our equation 2. Now, if we add up, okay? If we try to add up equation 1, add equation 1 and equation 2, okay, will be having this. The T's will cancel so that we need not to get the tension anymore. So you have 2T minus M1G plus the equation 2, we have M2G sine 32 degrees minus T. And of course, the right side will also add M1A plus the right side of this, M2A. So as you can see, class, what happens here is that T minus T cancels. So we need not to solve for the T. So you have M1G plus M2G sine 32 degrees equals, we need to get the acceleration. So the acceleration is both common. So factoring, we have a quantity m1 plus m2. So that's what we are trying to solve, the acceleration of the system. So yeah, if you have this, what will happen? You have already, let me rewrite, m2g sine 32 degrees minus m1g, okay, equals a times m1 plus m2. So dividing both sides by m1 plus m2, okay, you know what will be the result. So m1 plus m2, we have cancelled here, m1 and m2. So now we are freely can get the acceleration by m2g sine 32 degrees minus m1g all over m1 plus m2. So we already have the given. We have m2, 5.5. So we have 5.5 times 9.81 sine 32 degrees minus m1 is 2 kilograms times 9.81 all over m1 plus m2. So our m1 is 2 plus 5.5. So, and that will be the acceleration of the system. Okay, what's the answer? That's 1.2 meters per second squared. All right. So we use the systems of equation wherein we just add the equation 1 and equation 2 so that to eliminate the tension, we need not to solve the tension anymore. Okay? And we find the acceleration of the system. Okay? That is for number 3. It's fun. I hope you are learning so much, okay, in this video. And, just, physics is my favorite subject. It's very, very nice to solve some problems like this. Okay? So, for problem number 4, we are going to solve another problem. Okay. So, to start a 500 Newton crate moving across a level floor, you have to pull 230 Newton horizontal force. Once the crate starts to move, you can keep it moving at a constant speed with only 200 Newtons. Okay? What are the coefficients of static and kinetic friction? Of course, we know that frictions are the opposing force, okay, that opposes the direction, the opposite direction to which it is being pulled. Okay? So that's the friction force, the opposing force to the movement or direction of the movement of the object. Okay? So it says that we have a weight of the crate, that's 500 Newton. And to start a 500 Newton crate moving across a level floor, you have to pull it with 230 Newtons. Okay? So what is that 230 Newtons? So we have two situations here, the static and kinetic. Once the box starts moving, we have kinetic friction. And once the box is about to move, we have static friction. So for the static friction, we need first, the static friction is F sub S mu sub N. Okay? So we are going to determine the coefficients of static friction. So the free body diagram, just before the box starts to move, it says we have weight and we have the normal force because it's touching the ground. And in order to move that 500 Newton crate, we have to apply a 230 Newton horizontal force. That is what is being said here. Just before it moves. So of course, we know that just before it moves, in the opposing direction of the force, we already have the static friction opposing your pulling of 230 Newtons. Okay? So that will be our static friction. So if you that is the free body diagram already, okay? And just before it moves, the summation of f of x is still 0. Okay? Because we are talking about the static friction just before it moves. So if you have that, that would be the tension. This is the tension, okay? Tension minus the static friction or static friction force. T minus Fs equals 0. Okay? So now, so the tension, okay, equals the Fs. Okay? And what is the tension? The tension is 230 newtons equals the static friction force. Okay? So of course, our static friction force is 230 newtons. Okay? But that is not what is being asked. What is being asked is the coefficient of static friction, mu sub s. So F, using the formula F sub s, mu sub s times n, we can find this coefficient of static friction. So you have coefficient of static friction, static friction all over n. But the problem here, we already have the Fs, the static friction, but we don't have the n. So we're going to have summation of forces along y. Of course, it's not moving, so it's 0. So in order to get the n, the normal force, we have n going up minus weight is going down equals 0. So static, the normal force is still equal to the weight of the crate, which is just 500 newtons. So now we can get static friction coefficient, static friction all over the normal force. So we have static friction of 200 newtons and all over 500 newtons for the weight. So the coefficient of static friction will now be 0.46. Okay? So that is just about before the crate starts to move. How about the kinetic friction? Okay? Once the crate starts to move, you can keep it moving at a constant speed with only 200 newtons. So, again, once it starts moving, okay, the free body diagram is still W, and we still have Newton or normal force. Once it starts to move, meaning you only have to pull it with 200 newtons. That's what is the problem is saying. So the pulling is now 200 newtons. The tension, okay? The tension here. Now, since the box is already moving, we have an opposing force, friction, and that is what we call the kinetic friction. Okay? But if we are going to get the summation of forces along x equals ma, since it's moving, the problem states also that when it starts moving with a constant speed. So meaning, the acceleration is 0 because we have a constant speed. So you have tension minus the kinetic friction equals 0. So tension is still equal to the kinetic friction. Okay? And the kinetic friction is coefficient of kinetic friction times n. So we are asked to find for the coefficient of kinetic friction, and that would be kinetic friction all over n. Okay? So the tension equals the kinetic friction, that is 200 newtons. But the problem, we don't have also the n. So we have summation of Fy equals 0 because it's not moving along y. So using this free body diagram, we have a normal force going upward minus the weight equals 0. So the normal force is just simply equal to the weight, which is 500 newtons. And again, using this formula to get the coefficient of kinetic friction, we have mu sub k equals the friction. We have the friction of force of 200 newtons, and we have 500 newtons here. Okay, so that would be 2/5, or just simply 0.4. That's the coefficient of kinetic friction for this problem. Okay, and as we can observe that the coefficient of static friction is much greater than the coefficient of kinetic friction. Okay, because the friction is much higher, okay, when the object is static. Okay, but when it starts to move, we have the kinetic friction. Okay. So, that is for problem number 4. How about for problem number 5? Okay, so we're going to solve another problem here involving friction. So, the problem becomes a little bit difficult when we are involving with friction rather than a frictionless. Okay? Find the coefficient of static friction force if the block starts to slide down at an angle of 12.5 degrees. So as you can see, this will be our free body diagram. So you have the weight here. Okay, that's the weight mg. So you have, of course, components of weight in terms of x. Okay, that will be mg sine. Okay, and then we have in terms of y, that would be wy. This will be wx. And then we have a theta. So the theta is always from the weight, the direction of the weight to the what? Y-axis. Okay, so that will be the theta. Okay. So again, in order to get the static friction force on the left side, okay, since the block is going to the right, sliding to the right, we have a friction, static friction. It's about to start to slide to the right. We have a static friction and we have a normal force. Okay, here. Okay, so yeah, the coefficient of static friction is F sub S all over N. Okay, so from the formula, static friction equals mu sub S times N. So we need to find the mu sub S, we need to find the F sub S and N in order for us to solve this. So if we're going to get the summation of forces along X, it should be 0 because it's about to start to slide. So there is no acceleration in here. Okay? So, of course, the Wx, we have going to the right, we have the X component of the weight minus the friction force that is opposing it. That's the static friction equals 0. And again, okay, the Wx is basically mg sine. So that's W sine of theta minus Fs, wherein W is mg sine theta minus Fs equals 0. Okay? So simply, the static friction is mg sine theta if we just transpose this to the right side. So that's mg sine theta. So we are not given anything. We cannot solve that except for the angle. We are just given the angle 12.5. So we can substitute now this Fs here at the numerator. But we should get also the summation of Fy. Okay? Because we are going to get the N. And summation of Fy, again, going upward is the normal force. And going downward is the Wy. The Y component of the weight. And it is equal to 0 because, of course, it's not moving up and down or vertically. So you have N equals Wy. And Wy is W, of course, cosine theta. And W is mg cosine theta. Okay? So the normal force is mg cosine theta. Now we also have now the normal force and we have this static force. Okay? So if we substitute it with the coefficient of mu sub S equals F sub S all over N, the F sub S now becomes mg sine theta all over, we have mg cosine theta. And as you can see, the mg's will cancel. You are left with sine theta all over cosine theta. And by definition, by identity, sine theta all over cosine theta is equal to tangent theta. So you have tangent theta. So technically, the coefficient of static friction is just simply the tangent of theta. We already have the theta, that's 12.5. We have tangent of 12.5 degrees. Okay, and that would be 0.22. That's the coefficient of the static friction of this box. Okay, so I hope you learned something from this. Okay, going to our number 6. Okay, problem. Just a harder version of what we have solved a while ago. So what is the acceleration of the toboggan loaded with students of a total mass of 500 kilogram sliding down a slope. Assume that the inclination is 15 degrees and the coefficient of kinetic friction is of the slope is 0.08. So now we already have a static or kinetic friction here. So if we do the free body diagram, this will be your still the weight of the students or the toboggan. You still have the normal force here. Okay, so this will be our y-axis, so of which we have wy here, and of course we also have our wx here. Of course, this will be our wx, and our angle is alpha or 15 is here. Okay. Okay, what are the forces acting on the toboggan students? Okay, we have the weights, we have the normal force. Also, we have a friction. Okay, so it's not frictionless, so it's opposing to the direction of the movement of the students. Okay, or the toboggan. So that is what we have, and we are asked to find for the acceleration of them. Okay, so first we have to get the summation of f of x. In terms of x, we have a movement. Okay, we have ma. The problem doesn't state constant velocity, so we have ma. So summation of f of x, we have wx minus the kinetic friction equals ma. Okay, so for the wx, we know that that would be sine. Okay, because this is the adjacent side of the w, adjacent to the angle, so this would be cosine, and this one should be sine. So we have w sine of 15 degrees. That's the alpha. Then fk equals ma. Okay, so we have w is the mg sine 15 degrees minus fk equals ma. Okay, so we have the mass. Okay, we have two unknowns here. We can have the mass, but we don't have the friction force and then the acceleration. So we just simply write it as it is. Okay, so and then summation of forces along y it should be 0 because the toboggan students are not moving up and down. Its direction is in the x. So we have normal force positive minus wy equals 0. So the normal force is equal to the wy, which is wy is w cosine 15, which is mg cosine 15 degrees. So the normal force is just mg cosine 15 degrees. Okay? So if we know the normal force, if we know the coefficient of kinetic friction, we can get the Fk. So because the kinetic friction is simply the coefficient of kinetic friction with respect or multiplied by n. So you have 0.08 times mg cosine of 15 degrees. So we have 0.08. Okay? So we have m, the m of the toboggan, 500 kilograms, times 9.81 meters per second squared, cosine 15 degrees. So the kinetic friction will now be 379.03 newtons. Okay? So that's the kinetic friction, but that is not what is being asked. What is being asked is the acceleration. So from this, what we have got a while ago, we can rewrite it as mg sine 15 degrees minus 379.03 equals a all over the mass. Okay? So if we do that, we have the mass, we have 500, we have the g 9.81, we have sine 15 degrees minus 379.03 all over 500. Okay? That's the mass equals the acceleration. And you will soon find out that if we did that, okay, let's try that in our calculator so that you'll be guided. So you have 500 times 9.81. Then we have sine 15. Make sure you are in degree mode. Minus 379.03 all over 500, the answer is 1.78. Okay, rounding off to the nearest 2 decimals. So you have acceleration 1.78 meters per second squared. And this is our answer for the acceleration of them. Okay? Their acceleration. Okay. So if you just know how to do the free body diagram, analyze, okay, summation of f of x, f of y, then we will not be having any problems here. Okay? So for second to the last problem, we have problem number 7. Okay, we have problem number 7 here. A hockey puck on a frozen pond is given an initial speed of 12 meters per second. So we have an initial speed. Okay, V naught, that's 12 meters per second. If the puck slides 60 meters before coming to rest, so it traveled 60 meters along X before coming to rest, so the final velocity must be 0, and the distance traveled along X, delta X or S would be 60 meters. Okay? Determine the coefficient of kinetic friction between the puck and the ice. Okay. So we have, this is the puck. We have normal force, we have weight, we have the motion in here, and we have the opposing force in the direction of the motion, that's the kinetic friction. Okay. So what are we going to do here? Of course, the kinetic friction is mu k times n. So in order to get the mu k, we have kinetic friction all over n. Okay, but the problem is, we don't have kinetic friction, and we don't have also the normal force. Okay? So, yeah. We don't have the normal force. So, if we get the summation of forces along y equals 0, that would be normal minus w equals 0. The normal is just simply w, which is just mg. But we don't know the mass of the hockey puck. Okay? So, if we do summation of forces along x, of course, okay, the pucky is in motion. So, you have m, the mass of the pucky. Okay, take note. Is the pucky accelerating or not? Okay, so we have ma. In fact, it's decelerating. It's not having a constant speed, but it's decelerating because after it has traveled 60 meters before coming to rest, okay, it has traveled 60 meters before coming to rest. So, meaning, the puck is not accelerating but decelerating. So, that in terms of acceleration, the acceleration should be negative. So, if we have summation of f of x, that would be m times negative a because it's decelerating. So, we can have negative ma. We have summation of f of x. Okay? It's decelerating. Now, analyzing the summation of f of x. So, do we have any force here? No, we don't have. We don't have any force. It has given only initial velocity. So, we don't have any force. So, that would be to the right would be 0. Minus the opposing force on the direction would be fk. That would be negative ma. So, that we have negative kinetic friction equals negative ma. So, if we multiply both sides by negative 1, the negatives will cancel. Okay? Yeah. So, we now have the kinetic friction as ma. Okay? And the normal force, we have the normal force here as mg. Okay? Kinetic friction as ma. The coefficient of kinetic friction is kinetic friction all over normal force. So, you have coefficient of kinetic friction is, or the kinetic friction is just ma. All over the normal force is mg. So, we have cancel m. So, for us to solve the mu sub k, we have a all over g. But the problem is, we don't know the acceleration. Okay? Or the deceleration. Okay? So, from our given here, we have v naught, 12 meters per second, v equals 0. and delta x or s would be 60 meters. So we can use the kinematic equation of v squared v naught squared minus 2a delta x, wherein we can get a. So you have v naught v squared minus v naught squared all over. Okay, we have here negative 2 delta x equals a. So our v squared, the problem says it has traveled 60 meters before coming to rest. So your final velocity is 0 squared minus the initial velocity is 12 squared, 12 meters per second squared, and negative 2 times delta x, it has traveled 60 meters. So 60 meters equals a. So that would be a equals, we have negative of 144 all over negative 120. Okay, negative 2 times 60. So our acceleration, negative of negative, that becomes positive, so that we have 1.2 meters per second squared. And we already have now the acceleration, so we can just input this acceleration, 1.2 meters per second squared all over the 9.81 meters per second squared. The units will cancel, so you are left with unitless kinetic friction, or kinetic coefficient of kinetic friction, that is 0.12. So our answer is the coefficient of kinetic friction is 0.12. This is our answer. It's just simply A all over G. Okay, for our last number for this video. Okay. So you have this problem, number 8. I hope you are learning. So find the acceleration of the system. This given system of M1, 5 kilograms, M2, 1.5. F, we have an F pulling this mass 1 at a certain angle with the horizontal. Mu sub k 0.12 and theta is 28 degrees. So first things first, we have to analyze the free body diagram. So FBD for M sub 2. Okay. Acceleration is being asked. Okay, so this is connected with a cable. So the acceleration of mass 1 is equivalent to the acceleration of mass 2. So for the FBD of the spherical ball that is hanging, so we have the weight 2, okay, W sub 2 indicating the weight of the second object, okay, and then we have the tension. Okay, we also have an acceleration. So if you get the summation of Fy, that would be tension. Okay, sorry. So summation of Fy, that would be M sub 2 times A, because it's labeled as M sub 2. So summation of Fy, T minus W2 equals M2 times A, of which the tension or the weight is M2G equals M2A. Okay, so that will be our equation 1. So just leave it just there. Okay, this is our equation 1. Okay, how about if we try to have the FBD of mass 1? Okay, so this is our mass 1. So you have weight, you have normal force, you have tension in here, you have a force here. Okay, of course you have F of X here, and then you have F of Y here. Okay, and of course you also have, okay, kinetic friction force here. Okay, so if we do the free body diagram, that would be weight 1, we have N, we have force, it's being pulled. So we have components of force, we have Fx. We have components of force, we have Fy also here. And we have friction, okay? Friction force. Okay, and then also we also have tension. Okay, we also have tension. So, The fx, obviously, that's f cosine theta. The fy, that's obviously f sine theta, where theta is 28 degrees. So again, we get to have summation of f of x because we are after the acceleration in terms of x. Okay? In this FBD for M2, we did the acceleration summation for y because the acceleration is in terms of y. So you have summation of f of x equals the m sub 1 times a. It's moving. Okay? It's not constant speed, but it's moving. So summation of f of x, we have, to the right, we have fx, x component of the force applied. Okay? Minus, we do have tension. Minus, we do have kinetic force, friction force. Okay? Then equal m sub 1a. Okay. So, and of course, we have fx is f cosine of 28 degrees minus tension minus fk equals m sub 1a. Okay, so this will be our equation 2. Okay? So we're gonna just simply add these two to cancel the tension because we are still left with f sub k. So now we need still to find f sub k first, okay, before we can solve this. So we have summation of f of y for the mass 1 is 0. It's not moving upward and downward, so it's 0. So now we have normal force going upward, Fy going upward, minus W1 going downward equals 0. Okay? So we need to get the normal force because it's actually friction, kinetic friction is mu sub k times n. And we have mu sub k. We only have missing n. So we need to find n here. So that will be W1 minus Fy. Okay? W1 is M1G and minus Fy, the applied force in terms of y, that would be F sine theta. So M1 is 5 times 9.81 minus the applied force is 25 sine of theta, which is 28 degrees. So the normal force then would be 37.31 newtons. Okay? So that will be 37.31 newtons. So now, from our equation, we now have f cosine of 28 degrees minus t minus 37.31. That is our fk. Oh, I'm sorry. That is our n. That is not our fk. Okay? So, yeah. Need to be careful. This is only our n. To get the friction force, kinetic friction force, you have mu sub k, 0.12 times n, 37.31 newtons. So the friction, kinetic friction force will now be what? Okay, 4.47 newtons. Okay, so this is now what we are going to input here instead of 37. So that is 4.47 equals m sub 1a. So this will be our equation 2. So, equation 2. So if we add equation 1 and equation 2, adding equation 1 and 2, now we have t minus m2g plus we have f cosine 28 degrees minus t minus 4.47 equals m2a, okay, this one, m2a plus this one, m sub 1 of a. So we are asked to find for the acceleration. As you can see, the t's will cancel out. Tension minus tension. Okay? So you have negative m2g plus f cosine of 28 degrees minus 4.47 equals a times m2 plus m1. So divide both sides. You have m2 plus m1 by m2 and m1. So you now have a is simply, okay, negative m2. What is our m2? 1.5 kilogram times 9.81 plus f. Our F is 25 newtons. 25 cosine of 28 minus 4.47 all over M1 plus M2. That is 5 kilogram plus 5 point or 1.5 kilogram. So, if we do this in our calculator, we'll be getting 0.44 meters per second squared. Okay, so let's try. So you have negative 1.5 times 9.81 plus 25 cosine 28 minus 4.47 divided by, you have plus 5 plus 1.5. So you now have 0.44 meters per second squared. And that's all, guys. I hope you learned something from Newton's law applications. Okay, so I hope you enjoy watching this video, and I hope you learn more. Okay, you learn something about this video. Again, see you again on the next video. This is Engineer Abat. See you again on the next video.